Hey guys, my name is Trevor Smith. Welcome to Full Burn, where we kick some tires, light some fires, and interview awesome space and defense founders across the industry. Today, I am with Prashaanth Ravindran, and we are at Portal Space Systems. Now, you're the second one on the pod from Portal. Jeff was episode 1.
Yep.
And where are we today?
We're at right outside headquarters. Portal Space Systems is based out of Bothell, Washington. We are about 30 minutes north of Seattle. It doesn't feel like too far from Seattle, but we are pretty much all of us are based out of Washington. This is a Washington-based company, and we are glad to be in this space.
And we've got the good summer Seattle weather blessing us. A little cloud cover today.
A little cloud cover, but it gets better tomorrow.
Good. So, who is Prashaanth?
So Prashaanth started his life in his...
Are you going to speak in third person? No, please do. That'll be more
kidding.
That'll be more fun.
That was just, who's Prashaanth? No, I started my life in a little big city. I call it a little big city cheekily because it's a city of 11 million people.
Oh, wow.
And I grew up half a click away from the ocean. Lived there for 21 years of my life, went to school there, went to undergrad there. And then in 2002, came to the US for my master's degree in aerospace engineering. Studied in the University of Texas at Arlington. And then went on to do my PhD. Did a lot of fun stuff in school. I worked in detonations.
Detonations?
Yep.
As in things that go boom?
Yep.
Talk a little bit more about that. That sounds fun.
Detonations are essentially combustion, but supersonic. So a blast wave is a detonation, but where detonation in school is a shock wave keeps getting fed by the reaction of the fuel oxidizer behind it.
Okay.
So why it's interesting, it's probably the most efficient form of combustion that we can come up with.
Oh, interesting.
And
you work at a propulsion company now. So
right.
That come in handy, maybe?
It did.
Yeah.
Throughout my career, I've been interested in fire. I've played with a lot of fire, literally and figuratively.
So this was at school?
Yeah.
You were doing this? Okay.
Yeah. And I worked on combustion chemistries. I typically worked in numerical sciences, which is modeling. So I didn't really get to have a lot of fun blowing up things, but I did work in a lab, which did. So I always used to sneak and get to work some of my research work. We blew up in shock tunnels or hypersonic tunnels or detonation tubes, as we call it affectionately.
Man, that sounds fun.
Yep, it was. A lot of foundational research because, as you know, the industry is enamored with rotating detonation engines for a reason. RDEs are now used almost... The applications are getting endless. Recently, there was an RDE rocket that flew, but it's a long road. Detonations is a hard science.
Who was that?
Venus Aerospace.
Venus, that's right. Yeah.
Yeah.
So it fires in a circle.
Right.
Rotating, detonation, RDRE, RDE.
Pretty much. It's a shock wave that's in a chamber that keeps going in circle and circle.
So instead of a single long flame, you sort of see a flame go like this if you can see it in slow motion.
Right.
Yeah.
And it's actually fun. There are some cool clips of seeing it in slow motion. I worked on pulsed engines, so back before RDs became popular, it was easier to pulse the detonation waves.
Instead of doing it circularly, you're pulsing it. Okay.
So it sounds like a shotgun going off, literally.
Oh, wow.
But what you do is you inject fuel and oxidizer in pulses, and you set off a detonation wave, and you generate thrust. Why it didn't become popular? It was destructive structurally. The power-to-weight ratio wasn't making sense because we had to add so much structure behind it to hold it in place. And whereas RDs are a lot more efficient because it goes in a circle, it doesn't generate so much violent movement. It's a continuous wave instead of a pulsed wave. So the shock loading wasn't as
a little easier on the structure, chassis, frame of the.
It was absolutely for engineering. It was the best solution to go. But where RDs people struggled with it was to maintain that wave continuously.
Yeah,
you always had flame outs. It was so difficult. It happens you're talking about a tenth of a second on some of these waves, and it's very hard to tune all your fuel and oxidizer mixes in the right place.
So you're doing this in your early 20s?
Right.
Wow.
I did that as my graduate thesis, which was on detonation modeling. And
don't ask me what I did in college. Not as cool or as smart as that.
I'm sure you had a lot more fun.
we all learn different things.
We all learn different things.
Yeah, we all learn
there
different
you go.
things.
I did have a lot of fun. It was very rewarding, and then I started my career in the automotive industry because at the time there was a big demand for methane combustion, which was one of my research topics. And I started my career in automotive, worked there in 5 years, led a bunch of projects, had a lot of fun, but I really missed the ocean.
So you worked on methane engines?
Yeah.
Oh, okay.
Lean burn methane engines,
Interesting.
did waste heat recovery programs, how to make methane engines even more efficient through combined cycles.
Yeah.
And
so there's things that blow up. I'm seeing a trend here. Yeah, or things that could blow up.
Blow up.
So methane engines, and then where did you go?
And then got an opportunity to come to Seattle, and then Jeff ran a program at the time with StratoLaunch. He led the propulsion division for StratoLaunch, interviewed me to do propulsion modeling.
Yeah.
Really got excited to work with me because I was one of the few numerical people who was very application focused. A lot of CFD scientists, as I call them, are hardcore research people. But I have always had an eye on applications. I always was most interested in how do I bring all this research to mainstream? How do we make this marketable? How do I take complex problems and make it mass producible, right?
Right.
So I approached rockets in that way. When he interviewed me, he asked me about
Jeff Thornburg.
Jeff Thornburg.
So you met Jeff at Portal or before Portal?
No, this was before Portal.
Okay, so way before Portal.
Way before Portal. 8 years back, Jeff ran the propulsion team for StratoLaunch.
I was reading the article on your conference room wall.
Yeah, so StratoLaunch was an orbital launch vehicle platform. It's still there today. They converted that for a Talon hypersonic test bed. But at the time when Paul Allen owned it, one of the applications was air-launched rockets. And essentially the massive aircraft carries the rocket up 35,000 feet. And two-stage rocket air launches it from there to space. So looking at 100 to 200 kg payload capacities. Yeah, StratoLaunch was an orbital launch vehicle company. The idea was to carry rockets or hypersonic test vehicles up to 35,000 feet air in this twin fuselage giant aircraft that was custom made. And Jeff ran the propulsion side of it, where we build the rocket from clean sheet, from scratch, and take it up 35,000 feet, hydrogen oxygen engine, it launches to space.
Wow.
100 to 200 kg payloads. There was a heavy lift version as well, I think for higher payloads, but we wanted to get the main engine for the first stage, as we call it, and the second stage engines. And he wanted someone to do propulsion CFD modeling or propulsion analysis modeling.
Is it intimidating working on propulsion around a guy like Jeff?
Not really, because there's a lot of engineering alignment. I mean, Jeff is, I really loved his wide background. He came with a lot of hard-handed experiences, right? I mean, very difficult. The beauty of engineering is learning successes through failures. You fail a lot to learn what would be successful.
When you say fail, typically that means blow up, but
Yes.
Yeah.
I mean, there's no other way to fail a rocket than blow it up.
Rapid, unscheduled disassembly, as we like to call it. Yeah.
And, this was a conservative industry where you had to go through so many checks on, we don't want to have a failure in a test cell. But you come from a mindset where unless we know where we failed, we don't know how we can push our hardware.
Yeah.
We don't know how far our hardware could go. So it's kind of caught in a difficult world of how much can I push, but how much can I, keep the engineering programs moving, right? So the first conversations were actually very fascinating because first few conversations I had with Jeff, it didn't even seem like an interview, though it was called an interview. It seemed like a collaborative sit down and talk about ideas. And I really loved that mindset of, how would I do this? How would I do that? And then
if you're having a conversation in an interview, you're probably doing pretty well in the interview.
I guess. But I really, at the time, I really wanted to get back into aerospace. I really wanted to work on propulsion and combustion. He saw my background was very fascinating because I moved certain programs I did at Cummins, it actually went into production. And how we anchor the data that we see on the field back onto our models, and how we improve our processes. We went through a conversation of how I would typically, if he comes to me with a problem, I'm not the person to take it and go run and then give him the result. I would want to understand what is your sticking point here. So do you really need modeling? So I think the first thing he really loved about me was he asked me, so I would want to run a CFD model. I was like, hold on to that thought. Why do you need a CFD model? And
computational fluid dynamics.
Computational
CFD.
fluid dynamics. Yeah. And why would you need...
So for the audience,
Yes, sorry. Yes, I tend to drop some 3-letter acronyms.
No, it's okay.
But yeah, computational fluid dynamics is a robust 3D solution of fluid phenomena. And when you couple in combustion with turbulence and with all other fluid physics, it's a very heavy computational. I've worked with 1,000 to 2,000 processors in parallel.
Wow, that's a lot of compute power.
It is a very high performance computing, and it gets very expensive.
Yeah.
And so when we're trying to solve problems, it needs to have a meaning. Why would you want me to get to this level of complexity?
Right.
What does that buy you? What doesn't the first principles model buy you that this would, So the first question I asked was essentially that, why would you need this? Help me understand why you would need this.
Yeah.
And as we were talking through it, I pretty much said, I'm a very different kind. I consider myself an engineer with an expertise in numerical analysis. So if you ask me, I need a model, I would be the first person to say you probably don't. Yeah.
So would you say it's fair to say that you approach it from a first principles perspective?
I do.
When someone asks you a question, well, let's
Yes.
dig into the first principles to find out if it's the right
Exactly.
if it's the right question.
Exactly.
Yeah.
And what answers are we looking for? What problems are we trying to solve? And then what does the different levels of how you can put deep dives into the problem solving?
Yeah.
Different levels, go through it, and at some point you can stop, because when it comes to CFD, we can keep adding complexities and make it burgeoning.
More compute.
Exactly. And then there is a point of diminishing returns, because I might uncover a lot of cool physics stuff, but there's no way for me to see that in a test cell. So how could I bring that back and make it more repeatable, make my models more robust?
So how did you go from StratoLaunch to Portal? What was the bridge there?
After StratoLaunch ended because of Paul Allen's untimely death, the rocket part unfolded. But Jeff and I had such a tremendous working relationship. Jeff ran Interstellar, and I consulted for Interstellar as a numerical expert on helping him solve some of the problems. And meanwhile, I got an offer to contract with Blue Origin on the BE4 program.
Oh,
so I did that.
Nice.
Yeah, so the BE4 program was where I learned a lot more about how, when you go scale up big problems, big engines, and then cool things to solve, cool people to work with.
So you had worked basically with Jeff at 2 other companies before Portal. And so he really got to know you.
Yep.
So what was and I asked him this question, what did the day one inception of Portal look like? Like when he called you, how did that form? You were like, oh, we're gonna start a company. What was that day like? What walk me through what happened?
That was so I have my version, and I think I have my memories, but this is my clear memory, right? So Jeff and I, when Jeff moved to Kuiper, he moved out to here from Huntsville. We tagged up, and we actually had coffee chats. We like to meet up for Sunday coffees. It's like, what's going on? What's going on in your world? What's going on in my world? So we became a lot more friends than at that point. He's a fantastic mentor. He's still my mentor.
He's my mentor too.
Yeah.
Literally was my mentor.
Right.
through a program, but yeah.
And he has this amazing mentorship in him. Conversations turned to a lot of guidance and how I would do my job better.
Yeah.
And these conversations were alive even after Interstellar, and I moved to BE4. We kept in touch, and then he moved to Seattle. I was excited. So we kept meeting almost weekly or every other week, or at least once a month, right?
Wow.
And then he came up one day and said, where do you think the next challenge is? I was like, I don't know. The launch market looks so saturated, doesn't it? And he's like, precisely. We need to be thinking beyond. We are all looking at getting to LEO, but what do we do beyond that? And as we start through the coffee thing, he said, where do we think the next propulsion? Where can we? Delta V seems to be something that's missing, right? The coffee chat turned into a quick sketching thing. He brought up, what do you think about solar thermal?
Sketching a satellite at a coffee
Literally.
shop.
Started
Back
sketching
of the
concepts.
napkin, literally back of the napkin.
We started looking at it, and I'm a huge proponent of nuclear, peaceful uses of nuclear in space, and Jeff shares those values. We used to talk about, at some point, if you want to explore the cosmos, if you want to explore the solar system, nuclear is the way to go. But reality is, there are engineering risks, there are regulatory things to go around, and there are so many uncontrollable factors around nuclear beyond engineering that we cannot really dictate the future.
Regulatory
being a huge thing. Public acceptance, perceptions of nuclear technology.
So how do we build something impactful without being nuclear today? Yeah.
And solar was the easiest alternative. I can get that amount of energy, different engineering complexity, but how do I do that? How do I solve that problem? 2003, there was a program known as the ISUS, and what is that? Upper stage, solar upper stage, integrated solar upper stage. Sorry, I had to work both.
Integrated solar upper stage.
Yeah, so
got it.
In 2003, there was a program called the integrated solar upper stage. Essentially, test out the concept of solar thermal propulsion.
Yeah.
And the motivation behind this is, can we replace a kick stage or an upper stage engine from LEO to wherever we need to go with a solar thermal propulsion system? A lot of work went into it, combination with AFRL and maybe Lockheed or Boeing, I forget. But a lot of work. There was a launch. It was successful. But the market reality was, for all the complexity, you had a mature chemical propulsion system. And EP was just coming in. EP was becoming electric propulsion. Getting really popular. And a lot of the problems that, or the drawbacks that chemical propulsion had, with specific impulse, electric propulsion was solving that problem.
Right.
So in 2003, the prevailing thought was, in another 10, 15 years, EP will get up to enough thrust and enough specific impulse that it would overcome the drawbacks that current limitations of chemical propulsion.
Yeah.
And time went by, and EP comes with its own challenges, and we are now at one end of the needle with chemical propulsion, another end of the needle with electric propulsion, and there's this lovely spot in between
that also involves electrons.
Yep.
Yeah.
We can actually use
a lot of electrons.
Yeah, and solar thermal propulsion fills that niche because I can get up to 100, 200 Newton class thrusters, which is enough to move up to a ton in orbit.
Yeah.
Wow. And I use thermal propulsion to no combustion involved, heat up a propellant to high temperatures. Why we think Bothell has a different solution? Two things. Jeff and I are very passionate about additive manufacturing. We believe
about what
additive
manufacturing.
Yep. Very passionate about additive.
Yeah, I held that a little bit. It's about this big. I forget the name
thruster?
of it, but it gets really hot.
Yeah.
Yeah. Oh, that's the thruster. Okay.
Right.
I know. So,
so
he named he said the name of the metal. He didn't call it the thruster, but I was like, "Is this the nozzle?" And he's like, "Yeah, that's the nozzle."
Yeah. So the niobium C103 alloy.
Yeah. Very heavy.
Yeah, it's very dense, very heavy, but it's called a refractory alloy because the temperatures gets up to refractory levels.
Right.
You can get up to 1300 C and above.
Real hot.
Real hot.
Yeah.
And the good thing with any propulsion is the hotter you get the exhaust out, the more efficient it is.
Right. So if you could paint a visual picture and go look up portalspace.com or I think portalsystems.space. Thank you. But if you could paint a visual picture of what the satellite looks like, right? So normal satellite, but yours looks a little different because it's got some things sticking off the side.
Yes. So the secret sauce was the thrusters on additive, but we still need to get the thermal energy into our thrusters.
Right.
So we need to build giant mirrors, right? But we didn't want to build mirrors that has been done the way before. ISIS, the program, ISUS, which did the demonstration, used inflatable concentrators, giant inflatable stuff, which focused the energy.
Right.
We wanted something more mechanical, something which can fold, something which can stow away when we do payload operations.
Right.
So we pioneered a clean sheet operation of these mirrors with a partner company, where the mirrors would get stored when they are launched, like a flower, and then
it's like origami.
Pretty much.
Yeah.
It's very fancy origami because it could deploy in space and then it'll open up.
Yeah.
And
so you got these giant winged mirrors.
Yeah, it looks
plus
like
your solar rays.
Right.
And then the satellite with the thruster in the middle.
Right.
Yeah.
And
so you're like a little kid with a magnifying glass burning the ants on the ground.
Little ants.
Yeah.
But I love ants. I'm not going to burn any ants.
We won't say Death Star, but you know.
Well,
no, I'm kidding.
Well,
you're using it for propulsion purposes.
Yes, but we concentrate the power of almost 2,000 to 5,000 suns into this small 20 to 30 centimeter spot.
It's a very accurate mirror.
Right.
Wow.
And working with great partners, working with a good vision, and then finding out a ways to package all of this is that where a lot of rapid engineering comes in. We are a very small but very agile team. Team filled with a lot of expediency. We like to move fast.
You were in stealth mode for 2.5, 3 years?
Pretty much.
Yeah. And then you came out of the gate with a pretty big seed round at 18 million.
Yep.
So that's a testament to the team.
It is. The leadership is very capable. We have a lot of trust with the leaders to do our jobs. Jeff has a lot of trust in me to run engineering. I've run a lot of Tiger teams in the past. Small teams, capable teams, but running an organization is the next big level, and I feel confident I can do it, just like I feel confident Jeff can do his CEO job, can talk to people. I feel confident in our business development to reach out to our customers and explain our tech, but the engineering team I have may be small, but they are ferocious, right? I mean, literally we doubled our team in the last 1 month. We added 3 people to our team. And every single person we hire with the mindset they are future leaders.
Oh, yeah.
They are just not solving today's problems. I know they'll solve tomorrow's direction for Bothell, right? So we have a very clear team for mechanical design, for thermal analysis, for fluids, for structural. Just had a build engineer come in and take a lot of ownership. We got on a rideshare mission next February.
Yeah, you just announced your first launch. February 1st.
Correct, yeah.
Yeah, I just toured your facility. You're going to build a full sat in 5,000 feet.
Right.
And that includes offices.
Yep.
That's all you need.
Yeah.
You got some really unique equipment back there, which is really cool. Right. What is a story that you can share where a program went bad, sideways, you had to save it, or there was a customer or an investor that maybe you did something a little outside the box to either close the deal or save the program? Something blew up and, whatever.
Right.
Yeah.
Blue Origin was, more recently, I want to talk about recent experience because that really built up as a team, right? How we can function as a team.
Yeah.
In 2023, Blue Origin has a test cell accident where one of the BE4 engines did blow up. And I was part of the analysis team which worked with trying to understand why an engine which was in production mode could fail. And the failure mode analysis, I can't go into detail about it, obviously, but I uncovered.
Yeah, please don't.
Uncovered a lot of the stuff. But what was fascinating about it is when a group of very talented, very focused engineers come in to solve a problem, no problem is unsolvable. It's just the degree of how you can put resources and mindset.
Right.
And what's your tolerance for the answers. So 6 months later, the engine was back in production.
Wow.
And the problems were identified, solved. I'm very thankful for that experience as well because it molded me in working in a team, understanding how other people worked, how I contributed, how we can all bring together a program back online.
Yeah.
And with the leadership that worked with us as well.
Because those engines aren't cheap.
No,
they're not cheap.
And this is a 550,000 pound-foot thrust engine, oxygen stage combustion engine.
Wow.
So
it's a big engine.
It's a massive engine, and
how big? How big diameter? Just so people can how tall is it? How wide is it?
I could barely fit my shoulders through the throat of the nozzle, and I could literally the nozzle exit was about 5.5 feet or so. So I could literally fit the exhaust of the nozzle. So
would the full engine almost be the size of this car?
Oh. Much bigger.
Much bigger. Wow.
Much bigger.
Wow.
So, yeah, it's the 7B4s power the first stage of the New Glenn launch vehicle, and New Glenn was successful in placing payload in orbit, and unfortunately couldn't recover the first stage, but
Yeah.
they have a second flight coming out, who knows. But that was a great program, but I got bit into the fact that now I really wanted to work on something beyond LEO. The whole point of me coming into aerospace was, exploration. We wanted to develop capabilities that can go beyond Earth to different orbits.
LEO being low Earth orbit.
LEO's low
Yeah,
Earth orbit.
right.
Again, 3-letter acronyms.
It's all right. It's all right.
Beyond low Earth orbit, go to geostationary, go to cislunar orbits, go to the moon, and then beyond. And the more we learn about how to build out there, the more we learn how to build better on Earth.
Right.
For all the benefit of Earth. We want to bring those wisdom back to Earth and benefit humanity. So I was always a strong proponent of space exploration and bring those knowledge and wisdom back to Earth. And Portal was a phenomenal opportunity. Called in, Jeff said, need head of engineering. I was like, I'm right there.
You seem very passionate about this. Is Portal your first experience being part of the founding team?
Yes, it is.
So I have a question then.
Yeah.
You're a first-time founder,
Uh-huh.
as am I.
Uh-huh.
What advice would you give? Because you're 4 years in now to Portal?
Yep.
Yeah. So what advice would you give if you have like one or two pieces of advice for year zero founders, right? They got that sketch on the back of the napkin and they're like, I think I have a company here. What is something that they maybe should avoid or maybe focus on? What sort of like one pointer you could give to year zero founders?
So I have a very engineering focused mind, but one of the things I learned as a founder is to stop thinking of everything as an engineering problem and look at the people. I wouldn't call it the people problem, but look at the people.
Yeah.
Whom are you going to take your product for? A product may look cool. Ideas are dime a dozen. Execution is where it matters, right?
Yeah.
So we can all have cool ideas, but if you don't have the right mindset, we don't have the right people around you, we don't have the right customer base that you are focused on, whom are we going after? All of those affect the idea and the execution.
Right.
When we started Portal, our entire mission was, let's build a spacecraft. Let's look at active debris mitigation, for example, active debris removal, active debris mitigation. But our biggest goal was, no, we need to just give Delta V and let the market come to us.
What is Delta V?
Delta V is...
Besides a cool sounding thing. Yeah.
Delta V is, for a given mission, how much you can perform in that mission, right? So you have a set available propellant, your full gross weight of your spacecraft. At the end of it, you have no propellant left and your spacecraft mission is over.
Right.
How much total, how many orbits can you move?
Would you equate it to like the range of a gas tank? Like what range? Like, I've got
more
500
than
miles.
Range, it's how far you can travel.
Yeah. Yeah, so I meant like range. How far can this gas
that's
tank?
right. Yeah.
How far can this gas tank take me?
Miles per gallon is specific impulse, literally. But how far can the spacecraft take me?
There we go.
Yeah,
going the right way. There we go.
How far can we go? How far can my mission last? There you go.
This is Delta V?
This is thrust.
Oh, thrust, yeah. Woo!
Oh.
All right, better slow down before we get off the on-ramp.
Right.
Yeah.
That is good.
That was good. Propulsion.
Propulsion 101.
Propulsion 101.
Need for speed.
Yeah. All right. So
typically most of our current orbital capability, the Delta V is in the hundreds to 500 meters per second.
Okay.
We measure it as just because it's delta velocity, we measure it as meters per second. Our goal is to get into thousands of meters per second.
Wow.
Move it to kilometers per second, which gives us
changing orders of magnitude.
Magnitude. That gives us maneuverability from low Earth orbit all the way to geostationary orbit and maybe even back to mid Earth orbit, medium Earth orbit.
Yeah.
And challenges are how much can you carry propellant, how efficient your engine is. EP can do it. EP can potentially get to a high Delta V, but the technological jumps it needs to do and the time it takes for a mission to do that becomes limiting for it. Chemical propulsion, lot of high thrust, but delta
Right.
because we use propellant so
Low
fast,
range.
low range,
But it goes fast.
It goes fast.
Yeah.
So then it comes very close to this center island. With thermal propulsion, I can get up into 100 Newton range. So I can push a 1-ton spacecraft, and I can do it in a meaningful amount of time, and I'll still have enough propellant to do more missions.
It's like a hybrid,
Yep.
right? Just like a hybrid car. You got an
Right.
engine and a battery.
Yeah.
They kick on at different
You get
times.
the gas engine, and then you get your batteries to sit, and you can alternate between both modes, right? So that's why thermal propulsion is very appealing.
Yeah.
And the tech that we build today, I hope that we can extend that to nuclear thermal propulsion as well.
Jeff wants warp drive.
Yep.
Yeah, he wants warp drive.
Yes, we want to. I mean, in my lifetime, I'll be glad to go to Jupiter, right?
Yeah.
To go to Jupiter within a year and back, that would be cool.
That'd be impressive.
And at least go to the asteroid belts. The asteroid belts is a wealth of scientific and commercial interest that you can go up to.
Yeah.
Having a lunar gate post and then going to the asteroid belt and back and forth, bringing in some of the more rare earth materials that we still struggle with today, right?
Yeah.
So, but we have to start somewhere, and getting the orbital maneuverability, getting to where we can do some cool stuff in the orbits. Now that has defense implications as well.
Right.
Our current defense posture would require us to move orbits rapidly and as fast as we can, so that we can protect our interests in space,
Right.
protect our assets in space. So we came at that as a commercial angle, but then there was a lot of defense interest that was coming up. And
Dual use. Yeah.
absolutely. And then our mentality is, we are the last mile guys. We'll get you there. Once we get up to Leo, we want to get you wherever you want to go. We want to do whatever your payloads want to do.
Right.
And that's how Portal's vision expanded. Open up the orbits for everyone. And it's been cool. It's been I started last year with a one-person engineering team and started working on the additive side, getting contractors to help me do the design, put the spacecraft, and now there are 9 people working in engineering, and by the end of next quarter there are going to be at least 14 people working in engineering.
That's awesome.
So
all right, so we have I like to call it tinfoil hat corner,
there you go.
conspiracy corner, and also just hot take fun stuff.
Okay.
So since you work with Jeff and he's a friend of mine,
Uh-huh.
do you have an embarrassing story we could share with the audience about Jeff? Or is he just this perfect robot humanoid?
Oh, he's actually not. He's very passionate, and I know I don't have embarrassing stories. I have some cool stories.
Oh, well, give us a cool story
Yeah,
about Jeff.
well,
I really tried, Jeff. No
Right.
embarrassing stories, apparently.
No, I mean, he's very human. One thing I really liked about Jeff is he doesn't, he's very unfiltered. He likes to speak his mind. But I took that for granted in an engineering world. We all speak our mind in engineering. But how he pivots when he's in, when he's talking about engineering, he's passionate. We are talking about a lot of the cool stuff. We get right into it, drop a bunch of F-bombs, nobody cares. But then he turns around, and when there's the audience and he knows he needs to be a leader.
Right.
I noticed that pivot in him. In one of their conversations, we came up from a very rough conversation. I won't go to the details, but it was a conversation about engineering. We were, our heads were in, disagreeing, and then the other people were looking at us and wondering, are these guys fighting?
Do they hate each other?
Exactly.
No,
right?
you're just engineers talking.
And then they came to me and was like, do you guys don't like each other? Like, no. I mean, we love each other. I mean, like, what's going on? He's like, no, the way you disagree seems really, no. This is how we talk.
Yeah.
And then we pivoted, and then we started laughing and talking about it, and the people got like, what's going on? These guys, do they hate each other? Do they like each other? But I saw him, get up in a stage and change his demeanor. People try to push him in a corner, and he doesn't get pushed.
Yeah.
And that's the mentorship I really like from him. So there are some couple of cool stories like that. I don't really know any embarrassing stuff. I have seen him drive a tractor, and it's actually pretty funny. But
I would love to. I need a picture of that.
Yeah.
Jeff driving. If you can find it, we'll throw it on the video.
We will
throw it on the video.
Yeah. I've been to his lovely property, and I've seen Farmer Jeff.
Farmer Jeff. I can't wait to see Farmer Jeff.
And Farmer Jeff is cool looking and funny looking driving a tractor as anything. But
have you or anybody you know been visited by an alien or seen anything out of this world technology? Do you have like a real juicy, man, that looked really weird, what was that? Or, have you been visited?
No, but the first time I did see the Aurora Borealis, I thought, okay, man, that has to be something alien.
Where did you see it?
Out at Seattle.
In Seattle?
Last October we had this major solar flare, and we could see like north of Seattle where the skies are dark enough. I saw the Aurora Borealis for the first time. I took a whole bunch of pictures till 2 a.m. in the morning.
I was fortunate enough to go to Iceland.
There you go.
Last year, and we saw it in Iceland. Do you believe there are intelligent species out in the universe?
I think by the law of numbers, I'm going to give a very boring answer, but I think that's exciting. But just by the law of probabilities, definitely there are intelligent species out there. But if they are really smart, I don't think they'll try to communicate to anyone else.
Yeah. Well, we keep sending out signals left and right.
And I've always, I don't know if you have read the 3-body problem or that.
I watched the show.
The show.
Oh, right. I love that show.
Yeah, it's like, please don't communicate. The reply back saying that please don't stop communicating. So, no, I think there's a dreamer in me which grew up watching Star Trek and always wondering about, there should be some cool species out there, cool aliens out there.
Yeah.
But what are they doing? Where are we? There's something called the Fermi paradox.
Yes.
Based on, where is everyone? And then
got to be somewhere.
You got to be somewhere, and who knows?
So the answer is yes.
The answer is yes.
The answer is yes.
Are they here yet?
Have they been here?
I can't.
Have you seen any evidence that says that? Okay. All right.
Yeah, but have they been here a million years back? Who knows?
Who knows?
Yeah.
Some weird stuff buried in the ground.
Right? I mean, as a species, we are young. We have been around for a few 100,000 years as a species, like we're not walking upright, migrating out of Africa. 100 years of technological, growth. That we have the internet, we have fast cars, we have planes, we are going into space. We've been in space for less than 50 years?
Very, very young.
Very young species. And what's to say a million years back when the Earth was very different, we weren't visited.
Totally.
And they probably looked at it like, they're just rock.
Yeah, there's nothing going on here. We'll come back in a million years.
We'll come back in another million years and see what happens.
That totally could have been the case.
Yeah.
What technology from science fiction would you like to see in the real world today?
I'm a Doctor Who fan. I would love to see a phone booth which can take me across different times, time periods.
Oh, so time travel.
Time travel.
Time travel. That's a new answer. Okay.
That would be really cool.
Where would you go in this time travel phone
I'm
booth?
a history.
Or when would you go? When would you go?
I'm a history buff. Interestingly, everybody said if they have a time machine, they want to go into the future. I actually want to go into the past. I'm a huge history nerd. I've read volumes about Alexander and his march to India, volumes about Hannibal and getting into Italy, Genghis Khan, different civilizations.
It's fascinating. You could see it in real life. You could watch it.
Yeah, what if I could?
Would you hand him a cell phone and just ruin the whole timeline?
Kill the timeline.
Yeah, you'd rule the time. Like the timeline police would come out of nowhere and arrest you.
I would like to be the Outlander guy, right? Just be there, watching, observing what's going on. How do these people behave? What is it? What we read about them today, were they the same thing?
Yeah.
Was Alexander a nose picker? You know what I mean? we read about heroic exploits, but the guy, for all we know, would be just sleeping half his meetings.
So for deep space travel, is there a component of human psychology that you would remove? Or actually, which component of human psychology would you remove for deep space travel?
Oh, that's actually very interesting because human psychology is very complex, right? I don't know. If we remove anything about our psychology, would that make us less human? But that's a philosophical debate. I'll shove that to the side. I don't want to get into that debate. But the one component that we have to remove is fear.
Oh, fear.
Because fear makes us do... Fear is essential for survival, right?
Crazy things.
fear is needed for survival. Fear is actually helpful in a lot of ways, because through survival comes innovation. Through survival comes ways to protect ourselves. But what happens with fear, the negative effects of fear, is we stop understanding things.
Yep.
We
You stop looking at things in the right filter. It's too clouded with
too
fear.
clouded.
Yeah.
And then invariably what happens is, what we don't understand, we don't like. I'm an immigrant in this country. I saw the parts of it, people who didn't understand it. I experienced xenophobia in my life. And then I saw a lot of cool people who wanted to know where I was from, who wanted to know about my life story, who wanted to work with me, who wanted to, have fun with me, right?
That's awesome.
So that's the part of human thing that I got experience as an immigrant, first generation immigrant in this country. And when we travel and we encounter new species, new life forms, we would love to know more about them. And now, of course, there's a threat. If they have fear, and there's going to be a threat, and then there's so many things. But we shouldn't be the ones to lead with fear.
Right. That's a good one to pull out. Yeah. Jeff said boredom. Yeah. Which also I think is a good answer.
Which is a good answer.
Because if you're in a long space flight, on cryo, you get bored.
We should get board books.
So are you a car fan? Are you a car
guy? I am. So I'm a Formula One fanatic.
Oh, my man.
Who's
your team?
Ferrari
Who's your driver?
Guy.
Oh, I picked the perfect car.
Ferrari.
So we are in a
488 Spider.
488 Spider, and you said you liked the Spider.
Yep.
Yeah.
My favorite was, I probably date myself, my first poster of a Ferrari was a F40 Modena.
Oh, beautiful car.
Beautiful car, yeah. And I love the Maranello. And then more recently, the Pininfarina.
Yeah.
The Barchettas that Ferrari put out.
You're dropping some good ones.
Yeah.
So with a blank check, what would you go get? Today, what would you go get?
Oh, blank check.
Blank check.
Well,
as many commas as you need.
I would like to find a vintage 60 Ferrari. One of the first Enzos made. I love vintage cars. I have a 1974 Triumph TR6 I'm trying to fix. It's been a while. I need to get down and dirty and fix it. I have a passion for vintage vehicles. I have a vintage motorcycle, a 74 Yamaha RD400.
Oh, that's fun. I'm a motorcycle guy too.
Yeah, there you go.
Really anything that goes fast I can hurt myself in?
Yeah, pretty much.
Yeah. So what's the fastest you've ever been? Not in a plane, but on the ground.
On the ground. So I used to...
You can't get arrested for your answer.
Yep. Yeah. I used to race motorcycles.
Oh, me too. So, I was dirt.
Oh, yeah. So I was track.
Okay. I want to get into that.
It was fun. I used to do track motorcycles. The fastest, so I used to do 400cc, 350, 400cc.
Yeah.
The fastest I've been in that was 140 miles per hour in a motorcycle. In a 350.
And you did it safely because you're on a track.
I was on a track.
Everybody else answers they broke the speed limit on an interstate or something. But you did it safely on a track.
So on the road, I have been sometimes known to be impatient.
That's a polite way to put it.
And I've driven an electric vehicle till the governor kicked it. So I have a poster
they have
too.
governors. Okay.
And I didn't even realize they had a governor on. At 128 miles per hour, it kicked in. But on a gas car, I've driven in the Autobahn.
Oh, fun.
In Germany. And we had an M6. And I took the M6 all the way up to 270 kilometers per hour.
What's that, MPH?
I have to think about it.
For our American friends.
So 160 kilometers per hour is 100 miles per hour. So 260 is probably around 150, 160 miles per hour.
That is very respectable, sir.
Yeah.
Very respectable. I like it.
But it was still legal because it was on the Autobahn.
Yeah, well, if you're going to go fast, do it in the right areas.
There you go.
Right? Not on the road like some idiots, me including. Prashaanth, I've thoroughly enjoyed the conversation,
sir. It was an
sir.
absolute pleasure, Trevor.
We're back at Portal, and I enjoyed the ride. Thanks so much.
Likewise. Thank you for having me today, and this was also my first podcast.
So all right.
Yeah, I had a lot of fun. I've only listened to podcasts, and Trevor was kind enough to have me on one.
Absolutely. Do you have anybody you would nominate to be one of the next guests for the podcast?
From Portal?
No, not from anybody in the space.
In the space industry
or defense. or even the venture
I
capital
would
world.
love to hear Chris Hadfield. I have a tremendous respect for Chris Hadfield.
I have put him in a race car, but I have not had a chance to do the interview thing yet.
That would be cool.
Yeah, we have done a race car thing. Actually, it was Jeff's idea. We went to a private racetrack in Atlanta.
Oh, nice.
And I had one of my investors as a professional driver. We put him in a Porsche GT4 Cup car.
Nice car.
Roll cage, everything,
Right.
not street legal. And Chris Hadfield had a great time. But I do need to still interview him. So, Chris, it's coming, man.
Yep.
Very,
Chris,
very good.
Please do an interview. Big fan. Don Pettit is another astronaut. I love his photography that he puts up on Reddit. I love how he's so approachable on Reddit. Don Pettit would be an awesome guy to put in the car as well. Yeah.
Awesome, man. Well, I enjoyed it.
Likewise.
Well, thanks again for listening. My name is Trevor Smith. This has been Full Burn. Catch you next time.